and welcome to part 3 on the designer card game tutorial. So the end of part 2, just a quick recap, we had it so the cards took their place and had a nice rotation effect. What we're going to do today is we're going to have them find the position automatically. So for example, when I draw the first card, he should go right in the middle, not down this side over here. Okay. We also wanted to animate nicely, so when I click a card, it'll automatically go from here, flip round and take his place nicely. What I'm doing right now is just quality of life improvements. Basically, you want to make the game as clear as possible. If you want to skip this, then I'll suggest you skip to part 5, and I'll next work on putting the cards into play and get them to attack, etc. Okay, let's get started. First thing I'm going to work at is have it so the cards nicely take their place. They nicely animate from where the deck is to where you want them to go. In order to do that, I am going to head to my card base. I'm going to do a few new things here. So far this script is fairly bare. I'm going to add a few things to it. What I'm going to do, I'm going to use the states function, the finite state machine, where each card can have basically one of, I think it's 5 or 6 unique states it can be in. So for example, your card could be in your hand. It could also be moving from the deck to your hand. If I want to zoom in on the card, that would be another state. If I want to put it in play, then that would be another state, and so on and so forth. So if we can make these states nice and discrete, it can really help us organize our codes. To do that, we go to my card base. We are going to add an enum. And so we're going to enum all my states. So I think I want 6 states. The card could be in my hand, in which case it's basically sitting there and doing nothing. It could be in play. So let's add a function. I think I'm going to use a physics process rather than process. But it doesn't matter too much for this game. And first thing I'm going to do, I'm going to match my states. So depending on what state we're in, it'll tell us which bit of code to read. I also need to say what my start state is going to be. So their state, I'm seeing my default states I've put it in now is going to be in hand. And we can go through each of these. So it could be in hand. I'll just pass all of these and I'll do this for all. Okay, so what I'm going to work on right now is going to be move drawn card to hand. So it's going to animate from the deck to my hand. And it's also going to work on finding the right place. So I'm going to want something like this. I'm going to say find this position. That's going to have some sort of start position. And I want that to interpolate. So Godot is built in and it is called linear interpolate. And that is going to be going to the target position. And that will use a time variable I'm just going to call t. Let me just quickly have these as theirs. So all of these I'll probably define in the player space code. So one thing that Godot doesn't do is let you batch define theirs, which can be a bit frustrating in terms of getting your code looking a bit succinct. So by the end we might have like 10 theirs here, just basically doing nothing. Okay, also need to specify how long I want to do this interpolation. So I have a new var which I'm going to call draw time. And I'm going to say I want to just take 1 second to draw that card. And I'm going to enter this code and say if my draw time is less than or equal to 1, I want you to interpolate. No, I don't. I want to say if the time is less than or equal to 1, I want you to interpolate. And then I want to increase my time. So time will increase by delta. However, here I haven't used draw time yet. The way it works with this linear interpolation function is it will assume you're starting at time 0 and you're finishing at time 1. So this will always be a 1. The way we make it last longer, so say if I wanted draw time to be 2, you would have to basically stretch this time. So we would divide this, it has to be divided by a float, so it won't be a whole number of draw time. So basically what this does, this makes t tick on at half the speed of basically the game speed. So in fact it'll be 2 seconds in terms of game speed. So that's the way you kind of fudge it to work. But in this case I do want draw time to be 1. I don't want an else loop. if I've done all that stuff, I want to make sure I'm in my target position. So occasionally, if say time jumps ahead to like 1.002, I'll be slightly offset. You can have that as a quick correction. I would then want to say the state is going to be in hand. Once I'm at its position, and now want the in hand state. Really important, make sure you don't forget this. We now want to reset this timer. I want to reset it to 0. So next, if I draw it again, or the next card I draw, I won't be messing up. Okay, let's add some script that will work from the play space. So I need to define a start position and a target position. So this was my rect position. That is now going to be my target position. And I also want a start position. So my new card, it's start position. And I want it to start from this deck here. So let's get my node as a deck. Let's just call this position. And hopefully that'll be working. So a quick check. And it has gone horrendously wrong, which is always the way. Ah yes, so what I haven't done, I haven't told it here that its state needs to be the one that lets me move drawn card to hand. Okay, because otherwise I'm just at the in hand state, which just means do nothing. Here we get a slight problem. I'm not sure the best fix of it, but I've got a fudge. Here it doesn't know what move drawn card to hand is. That's because I'm using and defining my enum in my card base function. I tried to define it as a global variable, but either I messed up or it doesn't work that well. So I'm just going to fudge it for now. I'm just going to copy this defined enum and plug it into my main play space. Okay, and fingers crossed this will work this time. There we go. So it takes 1 second to move, and that works for all the cards. I need to do one slight thing. You can see we're starting, these cards will come in from here rather than coming from here. We need to offset our cards to make sure they appear from the top left. To do that, I want to shift it by the card size. So the card size is defined up here. I want its new position to be the deck position minus the card size that appearing in the center. So I want to halve this. And I think I can correct this as well. I think that this should have actually just been card size for it to work better. Let's see if those work. Yeah, that seems much better. Okay, next thing we can do, we want my cards to not appear at the correct tilt. We want to appear at the same tilt as the deck base, which is basically a rotation of 0, and then change it by the time it gets to the card hand. So we go to card base, and we're going to have another interpolation function. One of the slight downsides of this linear interpolation is it only works with vector 2s, and what I want to interpolate now is my rotation, which is just a number. Okay, to do that, if you wanted to go to a website, it'll give us some basic code for how to do that. So do the exact same thing with vector rotation. That is going to be, I'll call it the start rotation or start rot, and you want to times that by 1 minus time, and then you want to add the target position, so target rotation times time. Okay, and that will also quickly explain in it, when time is 0 and t equals 0, this term will vanish, this term will be 1, so when you start, we're at the start position. At the end, t equals 1, I've then got 1 minus 1 is nothing, so this term vanishes, and then it's target rotation times 1. So when t is 1, I'm at my target position, which is why this code works. Again, we need to find some more variables, so let's do that now. Also, I should have defined the last two variables as vector 2s because that's what they are. Okay, it's actually working great. Also, add my else loop that when it's finished, I definitely want to be exactly at my target rotation. So with my play space, let's add that in here. Let's just copy these two lines. My start rotation should be 0. It shouldn't have any rotation at all. And my target rotation, I think we define that. Yeah, let's define right here. Okay, and we don't need that anymore because so I run it, they'll nicely rotate into space as well. Okay, that was the first half of this. Next thing I want to do is I want to add a card back to it. I want when you draw the card to basically sort of see the card flip round. This is a fairly straightforward trick. First things first, I'll go into my card base. I'm going to add another sprite. And this will be my card back. Drag a sprite, I think there's one in assets. And it is card borders, back texture. This will be the back of the card. And we can see, there it is. And as always, make sure we have not set our offset. First thing we're going to do is we're going to sort out the size. So we've done that absolutely tons. If I go to my ready functions, where it is, yep. I just want to redo this bit of script, but this time with card back rather than card. I think to explain this best, I'm going to... Okay, I'll quickly explain how this is going to work. Cut away to segment on tablets. Assets, and it is card borders. This will be the back texture. Back of the card, and we can see, there it is. And as always, make sure we have not set our offset. First thing we're going to do is we're going to sort out the size. So we've done that absolutely tons. If I go to my ready functions, where it is, yep. I just want to redo this bit of script, but this time with card back rather than card. I think to explain this best, I'm going to... Okay, I'll quickly explain how this is going to work. Cut away to segment on. So from that, tablets. Assets, and it is card borders. This will be the back texture. Back of the card, and we can see, there it is. And as always, make sure we have not set our offset. First thing we're going to do is we're going to sort out the size. So we've done that absolutely tons. If I go to my ready functions, where it is, yep. I just want to redo this bit of script, but this time with card back rather than... I think to explain this best, I'm going to... Okay, I'll quickly explain how this is going to work. Cut away to segment on. So from that, tablets. Okay, my original scale, really straightforward. It's just going to be the rect scale.x. And if I don't do that, it will basically go wrong. So I just want to change it with reference to its original size. So rect scale is going to be the original scale, and we're going to times that by this following function. And it is going to be just the absolute value. Okay, looking at that should work. We're getting a slight error, which is that Orig scale isn't defined because it's declared in my ready function, and that's confusing it. So I think if I just take this here, I think we can just define it as an onReady instead, and then it should work okay. Let's give that a quick check. Yep, so you see the car is now rotating. We want to change now is when we get to the halfway point when it goes invisible for that instant. We basically want to delete the image of the card back. Back to my card base function, so add a quick if loop. So if t gets bigger than or equal to a half, this will only occur once, so let's add a test for this as well. We'll say if card back is visible. We then wanted to check if the time is greater than a half, and if it is, we then want to make that vanish. So I will let's go to the scene card back, and I want to change its visibleness to be false. Now it makes more sense if I just say that. So if we can see the card base, check if time is greater than a half, at which point we want the card back to vanish. So now when we run it, we see the halfway point, the card back vanishes, and also that looks like that card is flipping over. Okay, we're getting there. Last thing we're going to do in this part is how the cards automatically take their place. So basically the first card should always go here rather than to the right hand side. So let's get on with that. We are going to do a couple of things. In my play space, I need to sort out what this angle is going to be. Let's get rid of this for now. And we're going to add a quick little function that's going to automatically make it work. Okay, to work out the angle, did a fair bit of work. I'll cut to a quick explanation of it. So now when we run it, we see the halfway point, the card back vanishes, and also that looks like that card is flipping over. Okay, we're getting there. Last thing we're going to do in this part is how the cards automatically take their place. So basically the first card should always go here rather than to the right hand side. So let's get on with that. We are going to do a couple of things. In my play space, I need to sort out what this angle is going to be. Let's get rid of this for now. And we're going to add a quick little function that's going to automatically make it work. Okay, to work out the angle, did a fair bit of work. I'll cut to a quick explanation of it. So now when we run it, we see the halfway point, the card back vanishes, and also that looks like that card is flipping over. Okay, we're getting there. Last thing we're going to do in this part is how the cards automatically take their place. So basically the first card should always go here rather than to the right hand side. So let's get on with that. We are going to do a couple of things. In my play space, I need to sort out what this angle is going to be. Let's get rid of this for now. And we're going to add a quick little function that's going to automatically make it work. Okay, to work out the angle, I'll cut to a quick explanation of it. So now when we run it, we see the halfway point, the card back vanishes, is flipping over. Okay, we're getting there. Last thing we're going to do in this part is how the cards automatically take their place. So basically the first card should always go here. So we want to do pi by 2 plus the card spread. So card spread is basically how far apart these cards want to be, which I've defined as 0.25 from the end of part 2. And we're going to times it by this expression here, float, because otherwise it won't like being divided by 2. The number of cards in my hand, divided by 2, and then minus what card number we are. Let's define these variables quickly. So I'm going to say number of cards in my hand, 1 card number is 1 higher. However, for this code we don't need to do that, because when I create a card, it will always be the last card. So in fact, rather than card num, I can just have number of cards hand again. So it'll always be the very last card. What I want to do is then add some organizing script. So just before I add that new card, I'm going to go through all the cards I have. So for each card, which is a child of cards, so that'll be every card, because the one I'm just about to create. I now have to make sure that gets reorganized. To do that, I basically need to redefine all this stuff here. Redefine its new angle, rather than number of cards hand. That is going to be the other thing, card number. And again, I need to make sure that each time we start this for loop, we have the fact that card num is 0. Okay, from here, I can copy all this stuff across. So the angle is defined by this, And I can also define their start position, target positions, and same rotations. Okay, let's see how that works. Now I need to do one more thing first. I also need to update its state. I'm going to say state. I am now going to have to reorganize my hand, which is up there. That will now update its state. If I run it now, it'll do nothing, because in my card base there is nothing in reorganize hand. I basically want all this stuff again, copy through, with the exception I don't want to do any of the card rotation stuff. So let's see if that works. So one card is fine. Two cards. Now we're getting a slight mistake. They all seem to want to go here, which means I'm obviously defining my angle incorrectly. If I go to play space, yeah, what I've done here, I haven't increased the card number. So adding it on by 1, that should fix it. So first goes the middle, then we get 2, then we get 3, so on and so forth. So that's really nice. However, there is a slight bug in it. So if I draw cards really quickly, it gets a tad confused. What's happening here is, if I go to card base, I should be in the move drawn card to hand loop. However, because I clicked before this loop has ended, we're now switching to reorganize hand, and the main thing that messes up is that suddenly all this scaling stuff isn't working properly. So last thing we're going to do today is just quickly fix that bug. So we're going to say, if the card state is in hand, so if the cards do nothing, it's just in my hand, then all this stuff is fine, and I won't change any of that. So let's put a pass there for now. However, else, and I'll say else is if it's currently being drawn into my hand. So card state is move drawn card to hand. They want to change a few things here. First things first, in this case, I'm not going to say reorganize my hand. I'm not going to change what state it's in. I'm going to keep it in the same state. So this bit of code only wants to occur when I'm here. Also, I don't want to redo my position movements. Okay, so that's always going to cause a problem. So I'm just going to have this bit of code in here. The main problem I'm having right now is if I run it, you see that's a lot better. However, we get some weird jumping effects. So the problem is, I've got sort of my card deck here, and if I draw a card, it's going to happily go along to try and get to this position here. I'm going to say I draw a second card when I'm at this point here. That's going to change a few things. It's now got a new home, and we'll say its new home is here. However, if I don't do anything special in code, it's going to assume it was actually along this path instead, and it was on an equivalent point on this path here, so suddenly the position will jump. The probably best way to fix that I've found is we're going to create a false starting position. So I saw that's my finished position, but let's say for example I have done 9% of my journey. I've got 0.1 left to go on the journey. I'm then going to create a new start position, which basically puts it along the right line in such a way I've only got 0.1 left of the full start position's journey to do. We want to redefine our start position based on a fake start position. So let's add that now. I want this start position to be, as we just said, the target position. Minus the target position again, minus its current position, and then you want to divide that, what portion of the time left we have to draw that card. So let's get the notation we need. We have T, and it should take draw time to do it. Actually no, it shouldn't, it should only take 1 to do it. So I'm going to want to divide that by 1 minus card time. Okay, I'll add this in brackets just so nothing goes wrong. Okay, and that should be it. That was interesting. What have I done wrong here? There we go. That should be target position. There we go, it's looking a lot better. So if I draw 2 cards, they kind of go into the right place. We have a slight problem with the timings being slightly off. That's caused by the fact we're basically halfway through drawing a card, and then we shift the last card that's already in place, so timings don't quite match up properly. We can fix that, but I'm not going to right now. Just get a basic idea. All I want to do now is I don't want my cards to reorganize at the same rate they draw. So in my card base, I'm going to have a new thing called reorganize time. I'll say I want that to be a half instead. I just want my cards to reorganize in half the time it takes them to be drawn. That should be all I need to do. Let's check that's working, and if it is, we can call that a day. Yes, you can see the cards are moving a bit faster when they're being drawn. So we'll leave it there. In part 4, we're going to have it so if you mouse over a card, that card will zoom in, especially you can read the text a lot more clearly, and also have it so you can pick up and drag a card about. Okay, that's good. In part 5, we'll start getting actual gameplay implemented. As always, thanks for listening.